Okay, so for number 12, we're asked to find a series of questions. And the first question we're asked to find is the initial vector velocity of this object. So first we're going to start by writing out all initial conditions. And writing out all the initial conditions is going to help us to draw the graph of this object and find the equations that we need in order to solve the questions that it's asking. So first we know that x0 is 0, y0 is 100, vx0 is 50, vy0 is also 50, ay is -10, and this -10 is gravity, and ax is 0. So these are all the initial conditions of the object. x0 is 0, y0 is 100, vx0 is 50 meters per second, vy of 0 is 50 meters per second, ay is -10, so 10 in the negative direction or in the negative y direction, and ax is 0. So now that we have all of these conditions, we can go ahead and try to draw the graph, and this will help us to answer the problems. Okay, so the graph will look something like this. So we have, this is the y-axis, this is the x-axis. So we said before that x0 is 0. So we're not going to do anything with the x-axis. But, however, y0 was 100. So let's say that this is 100. This is where the object starts. So here, and we know that vx is 50. So that's how we can get this. This will be 50. And this is sort of the triangle that the graph will create. And this is the trajectory, the estimated trajectory. So now that we have this, we can try to find out the vector velocity. So it's very easy to find the vector velocity because we have this number here. So the vector velocity equals 50 meters per second. So we answered the first question. Find the vector velocity. 50 meters per second is the vector velocity. Now we can move on to the second part of the question, which is to find the angle that is made with the x-axis. So this angle here, we need to find that angle. So it's quite simple to find this angle. All you need to find this angle is to know that this angle is also equal to pi over 4. However, this is in radians and we want to convert this to degrees. So in order to convert this to degrees, we will get 45 degrees. So that is this angle right here, 45 degrees. So now we've answered the first question. We found the initial vector velocity, which is 50 meters per second, and we also found the angle that is made with the x-axis, which is 45 degrees. Now we can move on to the second part of the question. So the next part is to find the equations of x of t and also y of t. So we need to find both of these equations. And it's very simple to find these equations. So let's start with x of t. Now, in order to find x of t, it is basically 50t. The vector velocity times time. Very simple. So now we know x of t. Now we need to find y of t. Y of t is a little bit more complex, but it's not that complicated. Y of t is basically 100, which is the y0, plus 50, which is vx, times t, minus 5t squared. So let's write this out again a little bit nicer. So y of t equals, as we said before, 100 plus 50t minus 5t squared. So now we have found the equation for y of t and also x of t that we did before. The next question for number 12 is asking us to find the equations of v of x and also v of y. Now, these equations are very simple. Let's go to do it now. So we have vx. First, let's find vx. Vx is the vector velocity. 50. That is v of x, 50. Which is also the velocity. Now that we found v of x, let's find v of y. Now vy, similar to y of t, is a little bit more complicated, but it's easy all the same. So we have plus 50, positive 50, minus 10t. Now let's dig into why we have this equation. Plus 50 comes from this 50. It's going in the positive x direction. However, this is what we said before was the a sub y, which was negative 10. This is one of the initial conditions. So negative 10 comes from the gravity that is pulling the object down. So we have here a negative 10. You have to make sure that it's negative and then times t, times time. So this is the v of y equation. Now we need to find when the object will hit the floor. And this is quite simple to do. The first thing we need to do is figure out the equation for time. So we have x of t equals 50t. So basically what we need to do is solve for t. So we'll have that t equals x over 50. So this is basically our equation for t time. So now that we have this, t equals x over 50, we can move to plug in t, or x over 50, into y of t, which will be now y of x over 50. So let's write out this equation. So we'll have y of t equals 100 plus 50 x over 50 minus 5 x over 50 squared. So this equation will help us to now figure out when the object will hit the floor. So if you solve that equation, you will see this will give you 100. So at t equals 100 is when the object will hit the floor. And now we have solved the parts of question 12.